Hey everyone, ever wonder how many coin tosses it takes to get a specific pattern? Let's try a fun little puzzle. Imagine you have a fair coin, 50 to 50 chance of heads or tails. You keep tossing it until you see the sequence. Tail, head, head. As soon as you hit that pattern, you stop. The big question is, on average, how many tosses will that take? To figure this out, we can think about our progress toward that final pattern. We'll call these states. Our starting state is just, well, the start. Nothing's happened yet. If we get a tail, we move to the T state. We've got the first piece of our puzzle. If we then get a head, we're in the TH state, so close to finishing. And finally, if we get another head, we hit THH and the game is over. Let's trace the journey. From the start, if you toss a head, you've made no progress towards THH, so you're basically back at the start. But if you toss a tail, you've advanced to the T state. Now you're in the T state. What happens next? If you toss another tail, you're still just one tail away from starting the pattern, so you stay in the T state. But if you toss a head, fantastic. You've moved to the TH state. Now you're just one toss away. From T, if you get that final head, you're done. The pattern is complete. But what if you get a tail instead? That's a bit of a setback. Your last toss was a tail, so you drop back to the T state, ready to look for the next head. Now for the math, but don't worry, it's pretty cool. Let's think about the expected number of additional tosses needed from each state. Let's call them E start, ET, and ETH. From the THH state, the expected number of tosses is 0, because we're already there. From the start, you always spend one toss. Then half the time you get ahead and you're back at the start. The other half, you get a tail, and you're in the T state. So E start equals 1 plus half of E start plus half of ET. From the T state, you spend one toss. Half the time you get another tail and stay in the T state. The other half, you get ahead and move to the TH state. So ET equals 1 plus half of ET plus half of ETH. Finally, from the TH state, you spend one toss. Half the time you get a tail and go back to the T state. The other half, you get ahead and you're done. The game ends, so the expected future tosses are 0. So ETH equals 1 plus half of ET. When you solve these three simple equations, you get some neat results. The expected number of tosses from the TH state is 4. The expected number from the T state is 6. And the one we really care about, the expected number of tosses from the very beginning, is 8. So on average, it takes 8 coin tosses to see the pattern tail, head, head for the first time. Isn't that surprising? It feels like it should be more or maybe less, but the math gives us a solid answer. Try it out yourself and see how your results compare. Thanks for watching, and if you enjoyed this little brain teaser, be sure to like and subscribe for more.